On this 2019 to 2024 Ram 1500 Classic with the 5.7 Hemi P0073 means the PCM is seeing the ambient air temperature sensor signal high. In plain terms, that signal may be sitting too close to the top of the sensor circuit instead of moving normally with temperature. The truck may turn the MIL on, and the outside temperature value may be wrong or unavailable. The possible fault areas are the sensor connector, the signal or return circuit, the ambient temperature sensor itself, and only after the wiring and connectors prove out the controlling module. This is a 2-wire temperature sensor circuit, and it is typically a 5.0 volt sensor. As a general rule, a voltage reading above approximately 4.9 volts would set a circuit high/open fault, and a voltage below approximately 0.10 volts will set a circuit low fault. For the circuit low setting description, the threshold is typically in the 0.1 volt range. For P0073 and the circuit high side, the threshold is typically in the 4.9 volt range. Before getting deep into circuit testing, start with the basic system checks. Look for any updates or known fixes that apply to the code or symptom. Check the ECU for any battery voltage codes, because low battery voltage can set misleading faults. If other codes are present, check what they mean first and handle circuit faults before chasing rationality or performance faults. Then inspect the ambient temperature sensor connector before unplugging anything. Make sure it is fully seated and locked. After that, disconnect it and look for water intrusion, pushed out terminals, damage, corrosion, burnt terminals, or spread terminals. Also make sure the wiring information matches the exact vehicle build, because the ambient temperature sensor location and module path can change with configuration. Next, read and record all codes and captured operating data, and save a scan report if you may need it later. Review the captured conditions, the monitor gates, and the setting conditions. Then erase the codes and operate the vehicle or system under similar conditions to see if P0073 comes back. If it returns or the condition is present, keep going with the circuit diagnosis. If it does not return, treat it like an intermittent. For an intermittent, use the captured conditions to get the monitor to run again, and verify the failure mode is actually present before testing too far. Also check for applicable updates or known fixes before continuing. If none apply, wiggle test the harnesses the circuit runs through while watching for the code to become active or scan data to change. For the performance side of this sensor strategy, the monitor can run with the ignition on after an 8-hour cold soak on the previous engine off cycle, with ambient air, intake air, and engine coolant temperature values above -64 degrees C, -83 degrees F. A performance fault is usually based on the ambient temperature signal being irrational, typically not within 10 degrees C, 15 degrees C, 18 degrees F, 27 degrees F, of the other engine temp sensors. For an intermittent circuit high, a scope makes this easier. Connect the scope to the temperature sensor signal circuit and wiggle test the wiring while watching circuit voltage. If you cannot watch the signal live during the wiggle test, set a trigger to catch the event. For an intermittent circuit high fault, set the trigger for voltage above 4.9 volts. For the low side of the same style circuit check, the trigger would be below 0.1 volts for a circuit low fault. While you are there, do not skip the basics. Check battery condition and connections, identify and inspect related chassis grounds, and verify connectors are locked at components, modules, and in-line connections. Look closely for pushed out, corroded, spread, burnt, or broken terminals. One complete way to prove the circuit is with the electrical test lead kit. Connect the test lead to the temperature signal and sensor ground circuits at the temperature sensor harness connector. Move the switch between open and closed while watching the scan tool. Open should make the circuit high fault set, and if voltage data is available, the voltage should be 5.0 volts when switched to the open position. Closed should make the circuit low fault set, and the voltage should be 0.0 volts when switched to the closed position. Then move the switch to adjust and use the tool to vary resistance while watching ECU signal voltage on the scan tool. If the circuit responds correctly, the ECU and the two circuits are testing good, so the sensor or its connector becomes the likely area. Check the sensor connector again for terminal fit, corrosion, dirt, or damage before blaming the sensor. If the signal is stuck high, or only the high fault sets, think open circuit or very high resistance in either the signal circuit or the sensor ground circuit. Switch the tool closed, and if voltage is still present, move the ground side test lead to a known good chassis ground. If the voltage drops to 0 volts, the resistance is in the sensor ground circuit. If voltage is still present, the resistance is in the signal circuit. Check the correct circuit for high resistance. Typically, it should be less than 3.0 ohms. If the circuits are not excessive, check every related connector for pushed out, spread, corroded, or dirty terminals before condemning the ECU. If you are using a DVOM instead, keep both the temperature sensor and ECU harness connectors connected and locked. Turn the ignition on, then back probe the temperature sensor signal circuit at the sensor connector. If the signal voltage is reading between 0, 1 and 4.9 volts, the sensor signal is most likely giving a legitimate reading. If the fault is active and the scan tool value does not match the DVOM value, the ECU is suspect. If the signal measures a constant 0 volts, that points toward a signal circuit shorted to ground or an open between the ECU and the sensor, depending on which fault is active. If the signal is constantly above 6.0 volts, look for the signal circuit shorted to another voltage supply. If the signal is a constant 5.0 volts, that points to an open farther downstream, most likely the sensor or the sensor ground side. If the path takes you into disconnecting the sensor and ECU connectors, check the signal circuit for high resistance and short to ground. If the signal circuit checks good, inspect all connectors in the system for pushed out, spread, corroded, or dirty terminals before condemning the ECU. To check the sensor side in this conventional path, move the test lead over and back, probe the temperature sensor ground circuit at the sensor harness connector. If the next return point is not clear, pause, recheck the earlier diagnostic path, and avoid guessing. Even though this episode is focused on P0073, the same sensor circuit logic uses the low side check when the voltage data points there. With an active circuit low fault, you can quickly eliminate the temperature sensor as a possible cause by disconnecting the sensor harness connector while watching for the circuit high fault to become active on the scan tool. If the high fault becomes active, the sensor is the likely problem. If it does not, disconnect the ECU harness connector to isolate the circuit. Then check the temperature signal circuit for continuity to both chassis ground and the sensor ground circuit. Continuity there means the signal circuit needs to be repaired for a short to ground or to the sensor ground circuit. If the signal circuit is not shorted, the ECU only becomes a supported suspect after that isolation check. For the targeted circuit high check, disconnect the temperature sensor harness connector and measure the temperature sensor signal circuit with the ignition on. The signal circuit voltage should be between 4.9 and 5.6 volts. If battery voltage is present, repair the sensor signal circuit for a short to another voltage supply circuit. If the voltage is correct and the fault is active, watch the scan tool and jumper across the sensor connector terminals with the ignition on. Typically, the temperature sensor signal voltage should change to 0 volts on the scan tool with the jumper in place. If voltage data is not available, check that the opposite circuit fault sets with the jumper in place. If that happens, the sensor is faulty. If the voltage does not change to 0 volts or the opposite fault does not set, check resistance in the temperature sensor signal circuit and temperature sensor ground circuit. Typically, the circuit resistance should be less than 5.0 ohms. If either circuit is open or high resistance, repair that circuit. If both circuits test good and the signal is still reading high, check all related connectors again before condemning the ECU. For performance, rationality, or a hard-to-catch intermittent, disconnect the temperature sensor harness connector and connect the electrical test kit leads to that harness connector. Move the switch on the tool to open. The signal should read 5.0 0 volts and a circuit high DTC should be active or pending on the scan tool. Next, flip the switch to the closed position. The signal should read 0 volts and a circuit low fault should be active or pending on the scan tool. If there is voltage present between 0 and 0 volts with the test tool in the closed position, there is likely resistance in one of the circuits. To find which one, remove the test lead connected to the temperature sensor ground circuit and connect it to a good chassis ground. Then confirm the suspect circuit by isolating it and measuring resistance between the sensor and ECU harness connectors. If no resistance is measured, carefully check the connectors in that circuit path for spread, dirty, or corroded terminals. When checking the sensor itself, remember the actual resistance can vary +/10% form the values in the table. If a temperature table is available, move the switch to adjust, connect an ohmmeter to the test leads, dial the tool to a resistance value in the table, connect both leads to the temperature sensor harness connector with the ignition on, and watch the scan tool for the proper reading. Use the tool to vary resistance while watching the temperature or voltage signal. If the actual sensor temperature can be acquired or reasonably estimated, measure resistance across the sensor terminals and compare it to the table. The table points include -40 degrees C, -40 degrees F 345, 26 k ohms as the lowest possible temperature reading, -10 degrees C, 14 degrees F 53, 38 k ohms as a logical temperature value, -5 degrees C, 23 degrees F 40, 89 k ohms, 0 degrees C, 32 degrees F 31, 56 k ohms, 5 degrees C, 41 degrees F 24, 55 k ohms, 10 degrees C, 50 degrees F 19, 24 k ohms, 15 degrees C, 59 degrees F 15, 22 k ohms, 20 degrees C, 68 degrees F 12, 13 k ohms, 25 degrees C, 77 degrees F 9720 ohms, 30 degrees C, 86 degrees F 7780 ohms, 35 degrees C, 95 degrees F 6370 ohms, 40 degrees C, 104 degrees F 5200 ohms, and 150 degrees C, 302 degrees F 181 ohms as the highest possible temperature reading. If the reading matches the table during tool simulation, but the sensor resistance is not in range for the actual temperature, the sensor is likely faulty. If a table is not available, connect the electrical test kit leads to the harness connector, switch to adjust, turn the ignition on, and slowly vary resistance while watching scan data. The temperature or voltage value should change with the resistance change. If it does, that also points back toward the sensor. Only verify an ECU failure after opening and shorting the circuits while monitoring signal voltage and fault codes. If the expected voltage readings or expected fault responses do not happen when opening and jumping the connector, and the circuits are not shorted or open, then the ECU becomes the indicated fault area. Before condemning it, carefully check every connector in the circuit path for water intrusion, spread terminals, pushed out terminals, burnt terminals, or corrosion. After the repair, verify the repair and confirm the code stays gone. If the ambient temperature sensor wiring was repaired, the sensor was replaced, or the BCM connector was disconnected while correcting an active fault, the vehicle must be driven for a minimum of 5 minutes above 15 mph so the ambient temperature signal can update before the code will go stored and can be erased. The takeaway is simple. For P0073, prove the connector, the signal circuit, the return circuit, and the sensor response before you blame the ECU. For more diagnostic training, visit Diagnostics.com.